Chess is fun, but it's even better when you know where each piece can move. Playing on the computer makes it easy to see all the legal moves, but what do you do when you're playing over the board? Nick and I have developed an electronic chessboard, which indicates the possible moves of each piece and wherever they appear on the board. Now unfortunately, since we aren't electrical engineers, our electrical knowledge is only slightly better than our chess knowledge. Did you know that this thing's called a knight, even though it's clearly a horse? Here's how our chessboard works. We have 8 vertical wires and 8 horizontal wires. The horizontal wires just have resistors to prevent the circuit from exploding, but the vertical wires also have diodes as well. Now what this allows us to do is we can record each specific voltage for each tile by running through the horizontal wires one by one. Each chess piece has a specific resistance which will connect between the diode and the rows, causing a voltage drop for the circuit. We can now measure this voltage drop through the Arduino to determine which piece it is and therefore where it can move. So if you look at this 4x3 example, think of these switches as the Arduino pins. All the top ones stay on, while the side ones they continually change, and so there's only one that's on at each time. Pretend this wire is a chess piece and bam, voltage change. All the chess pieces properties are coded in Arduino, and since I couldn't get VS Code, DS Code or even CSGO working, we had to use Arduino IDE. We also 3D printed these resistor holders to make the project a bit cleaner. So in general terms, when you pick up a piece on the board, it will show you where the moves are. So what will it look like? Well, we have 3 main layers of the project. We've got the circuit I've just shown you, we've got the LEDs which will indicate the possible moves, and you've got the chessboard itself. Our final conclusion was to have a PCB board act as our chessboard and have the internal circuit built in within it, while the LEDs pop up through these holes. However, the parts didn't come in time, so we've had to improvise. We got 2 pieces of perf board and soldered the resistors and diodes on one, and the LEDs on the other.
I have finally finished wiring up the chessboard light set. Took a while, I haven't checked anything yet like a true engineer, so I have no idea if it works, but with a lot of help from determination and yeah, hopefully it will go well.
Eventually, when Nick finished the soldering and I finished it pressing the semicolon multiple times, the debugging stage began. And this stage was quite interesting, especially since he had the physical copy and I had the understanding of the code. So we had to play a game of Battleship to really figure out what was going wrong and how to fix it.
Alright, so this is testing the LED arrangement. It should go left to right, and then down one, and then left to right, etc, etc. So let's see how it goes. Alright, that's a problem.
After hours of debugging, we finally got all the pieces working as intended.
So we've got a pawn here. It can jump twice because it's in its starting row, or it can attack an enemy. And we can see this is our original piece. You can eat the black pawn, and the white pawn is what it is.
The only things that aren't implemented are the specialist moves such as en passant, castling, and whenever the king is in check. Nevertheless, the board was functionable and it was ready to play a game on. Now since Nick didn't have enough pins on his Arduino Uno to cover the entire board, we modified the chess game to be 4x4. Here's what the starting board looked like, where I'm black and Nick's white. There's actually a maiden 5 for white in this board, but the game didn't go that way, as Nick wanted to make the game interesting and give me a chance.
So I can take your pawn in the corner and I put you in check. What do you mean I don't have a bishop?
Now this is the part where I told him he doesn't have a bishop to block the check, and it turns out I was wrong.
I put you in check by moving my queen to the left.
That's not check, but I thought he was moving his queen diagonally left, so I didn't take his queen. Anyway, the game ended up as a draw. And what we learned was we are really bad at chess. We'll see how the thing works. This clearly isn't the finished product though. Soon we're going to implement the specialist moves that we were missing, maybe even different color features, and maybe showing the best possible move for each turn. That's why this is a 2-parter. So see you next week. Or maybe the week after that. Or the week